Welcome to the walkthrough for assignment 2B. The purpose of this assignment is to deepen your experience using Java 8 functional programming features and their integration with Java 8 parallel streams. In particular, in this assignment, you'll develop an app that uses Java 8 parallel streams to obtain, transform, and store images. The code you write for this assignment has a GUI and runs as an Android app. Please feel free to use this app to help debug your solution. The following resources may be helpful in completing this assignment. Detailed overviews of the Java 8 Parallel Streams framework are available in videos 32 and 33 in one of my YouTube playlists. Naturally, we'll cover this material in class, which will be available in my YouTube CS891 playlist here. Good overviews of Java 8 sequential and parallel streams appear here and here. I highly recommend you get the book Modern Java in Action to learn more about Java 8 streams programming. Before you complete the initial submission of Assignment 2B, you'll need to do the following. Complete your implementation of Assignment 2A, taking into account my review comments. In particular, it's important that your unsynchronized array implementation works properly, since it's used as the basis for the app in this assignment. Please come to office hours if you have any remaining questions about your Assignment 2A solution. The Image Crawler app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purpose of Assignment 2B, however, you only need to be aware of the following directories. The utils and crawler directories, which contain the skeletons you'll need to fill in, as described below. The app source test directory, which is a set of JUnit tests that exercise the features under test and can be used to evaluate whether you've correctly satisfied this assignment's requirements. And the app source Android test Java assignment 2B tests, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The application's minimum API is 26, so you'll need to select an emulator that uses API greater than or equal to 26. If you don't already have one created, you can create it by clicking the AVD Manager button in the Android Studio IDE. In this part of the assignment, you'll complete the implementation of an image crawler class in the Parallel Streams Crawler 1 Java file in the Crawlers folder. This class uses Java 8 Parallel Streams to perform an image crawl starting from a root URI to obtain, transform, and store images. Depending on the parameters used to run the tests, images from the HTML page reachable from the root URI are either downloaded from a remote web server or read from the local file system, and the results are stored in files. The bulk of the code for the app is provided in the skeletons. You should convert your sequential streams crawler class from assignment 2A to the parallel streams crawler 1 Java class in assignment 2B by making minuscule changes to use Java 8 parallel streams. You also have to complete the collector implementation in the array collectors.java file in the utils folder. Graduate students should use the synchronized class implementation from the last assignment in their array collector.java implementation. Undergrad students can ignore the synchronized array class and simply use their unsynchronized array class from the previous assignment. Your solution should use no loops in this assignment and instead use Java 8 parallel streams operations. The skeleton code for this assignment is available here on my GitHub account. Now that you've set up your GitLab account, you can pull the skeleton code into your repository, read it carefully, and complete the to-do markers. The JUnit tests in the image crawler folder are provided to increase our confidence that your implementation is working as expected. There's a lot of tests, and so you'll have to run them in order to make sure that everything works properly. Tests are cumulative as well. You'll need to learn how to use the Android Studio GUI to run the JUnit test locally on your computer, as described here. As usual, testing only demonstrates the presence of bugs, but not their absence. So don't rely solely on the JUnit test to detect problems in your code. Assignment 2B is designed to give you experience developing apps using the Java 8 functional programming features and Java 8 parallel streams without the need to program the fork join thread pool directly. The skeletons, JUnit tests, and so on are extensive, though you don't need to understand them all to complete your solution. Please ask questions in class, office hours, and on the discussion forums. Now that I've talked about the specification, let's take a look at the skeletons, starting with the skeletons in the utils directory. First and foremost, you'll need to copy over your solution from the assignment 2A's unsynchronized array class if you're doing the undergrad version, and if you're doing the grad version, you'll have to copy over the implementation for the synchronized array class. So once you've filled those things in, which should be basically the same as before, you'll have the grounds for beginning this assignment. What you'll have to do for this assignment is implement the array collector. As you may recall, a collector is a mutable reduction operation that accumulates input elements into a so-called mutable result container. And as you'll see, the reduction operations can be performed either sequentially or in parallel. And the grad students are going to do one version, which will be done in parallel, and the undergrad students will do another version, which is done sequentially, even though it's done in parallel streams. And we'll talk about that in class. So as you can see, the array collector implements the collector interface. You have to go ahead and fill in the toArray factory method, which creates a new array collector. So you have to fill this in here, replacing return null with the proper code. Then you have to fill in the various methods that are defined in the collector interface, starting with the supplier, which is a factory method that returns a supplier that in turn will create a new mutable result container that will hold all the elements in the stream. So for the graduate student version, you'll fill in a version that returns a synchronized array constructor reference. For the undergrad version, you'll fill in the unsynchronized array constructor reference. If you take a look here, the accumulator, that's a factory method that returns a by consumer that is used to fold an array into the mutable result container, which of course is created by the supplier factory method up here. And once again, you'll fill in the appropriate code here to replace null with the right implementation. Then there's something called the combiner, and the combiner has two variants, one for the grad students, one for the undergrad students. The undergrad students have to do actually real combination. They have to write some code that will combine things. The grad students, if you watch the videos, since this will be a collector that's a concurrent collector, you have to do something a little bit different, and it's actually very simple. But so don't get too distracted by the comment. Think carefully about what you need to do for this. Then there's a finisher, and once again, you have to fill in the right implementation for the grad students and the undergrad students, replacing null with the right code. That one's not too hard. And then over here, you see the characteristics method. And this is a factory method that gives the characteristics that describe the actual type of collector being created. And if you read the comments, you can see that the undergrads have to return a characteristics set that uses unordered and identity finish, and the graduates have to return a characteristics set that is unordered, identity finish, and concurrent. So the grad students are implementing a so-called concurrent collector, and you'll learn more about that when you watch the videos that we're going to go over or listen to what we talk about in class. So that's basically what you have to do that's new for this assignment. Over here in the crawlers folder, it's also very straightforward. The thing to do here is obviously make sure you've implemented your sequential streams crawler correctly, and you'll have to fill in the blanks from what you did from assignment 2A. And then for assignment 2B, you'll have to implement the parallel streams crawler. And this implementation is a very straightforward revision of the sequential streams crawler.java file with only minuscule changes to use parallel streams instead of sequential streams. So obviously I've given you the perform crawl method, so you don't have to do anything there. The crawl page method you have to fill in, and this again is very straightforward. And then process image, also very straightforward. So if you've got sequential stream crawler working properly, converting it to parallel stream crawler 1 should be a piece of cake. And I did this deliberately. This is a short assignment. It's meant just to demonstrate how easy it is to go from sequential streams to parallel streams. And of course, the interesting part will be when you run the tests, you run the instrumentation tests, so you run the app, and then visually see the difference in performance. And I think if you have a multi-core platform, you'll really be amazed at how much faster it runs. And that's one of the points I'm trying to get across with this assignment, is how you can go from sequential to parallel with minuscule changes and get dramatic speedups in your code. When we do assignment 2C, you'll do something more interesting for the parallel stream crawler 2 implementation. But we'll talk about that next time. Now that I've described the specification and the skeletons, let's go ahead and run the tests. As you can see, the tests are cumulative. They test what you did for assignment 2A as well as for assignment 2B. We'll start by running the assignment 2A tests, These, of course, should hopefully work properly from what you did before, because if you followed my review comments and test work previously, they should work still, hopefully. So here you can see that I ran the assignment 2A tests. These tests test the array split iterator, they test the sequential streams crawler, and then there's also some tests that are done for the grads. But as you can see, we have lots of different tests that run, and this hopefully demonstrates that everything is working properly, which is good. Then let's go ahead and run the assignment 2B tests. They're going to go ahead and start off as well. As you can see there, we're testing the parallel streams crawler 1 implementation as well as the array collector tests. So make sure you run all the tests. It's very important to run these tests. Do not submit your program without running them, because if there's mistakes, this is sort of free points to run these tests and fix them before you submit in order to get your grade. So as you can see, my implementation works properly, which is a good thing, and yours should do the same. If you have any problems, of course, please don't hesitate to ask. Now that we've talked about the specification, the skeletons, and the unit tests, let's talk about running the instrumentation tests. So if you go into the app folder under the Java folder in the assignment 2A or assignment 2B tests, then you can go ahead and run the instrumentation test. And this will go ahead and automatically run the tests and test a bunch of different parameters, demonstrating how it works automatically. I'm not going to show you that because it'll take too long, but I encourage you to run it. What I'm going to do instead is I'm going to show you how to run the app. So I've gone ahead and started up a version of the app in the emulator, and you can see here that I've selected it to run sequential streams version locally. And if I click on the little download button, you can see that this goes ahead and sequentially downloads and processes and stores the files. And you can see it's sequential because it's doing things one at a time. So let's go ahead and stop that because it'll take a while to run. What I'm going to do now is I'm going to go in here and I'm going to select, instead of the sequential streams version, I'm going to select the parallel streams version. So that's one of the menu options. These things are done automatically for you by running the instrumentation tests. So now that I've selected parallel streams, watch what happens when I click the download and run button. It's going to go a lot faster. Look at that. This is the demonstration of the power of parallel processing. Whereas before, it was doing all these things in one thread and one thread alone. Now it's doing all the processing in multiple threads. And I think you'll agree it is way, way faster than what we had done before. And that's really cool, and it really demonstrates the power of parallel streams. So go ahead and run the instrumentation test, and it'll do all this stuff for you in sort of an automated torture test manner. Or if you want some fun, you can go ahead and run the app yourself directly, as I've done here, and fiddle around with different parameters. And you can see how much faster this is. It took almost no time to do that because I've got a very powerful 6-core machine, so it's able to do all these things in parallel.